Hi, everyone. Welcome to the Oxford Quantum Information Society event. I'm Mert. I'm the president of the society. And today we'll be hosting Ricky Young from qBraid. So Ricky is actually an old friend of mine from Stanford. And he's going to be talking about really exciting stuff they've been doing at qBraid. Basically, they allow for accessible quantum computing for everyone. If I didn't know anything about quantum computing, and I wanted to start coding right away, I would probably go to qBraid. Correct me if I'm wrong, Ricky. And yeah, we have a few people here from the society as well, like Bansh is our events manager. Yeah, so we're gonna have a lot of exciting events this year. For example, we will be hosting Jack Hiddery on campus in 2 weeks. Yeah, stay on our newsletters and we'll send out the announcements. But yeah, Ricky, you have the floor.
Awesome. Thank you so much, Mert, for inviting me. Thank you to the Oxford Quantum Science Society as well. Bench, it's always good to see you and really excited to do this. I would love to do this super interactively. What's great about qBraid is, one, we have a lot less bugs now, and two, we can do an actual demo live. So with that said, first and foremost, I'd love people to, if you don't have an account, create an account on account.qbraid.com. And I will share my screen and walk everyone through it. If you could give me sharing permissions, that would be great.
Yep. Yeah.
While he's doing that, if you guys could log in through Google, that's a little bit faster, so you don't have to confirm your email. That's all taken care of by Google. So
I already have an account, just to put that out there.
Let's go. All right.
So do I. Just putting it out there.
Yep. There we go. Gotta love it. I think I have shared permission now. Great. Let me switch the tabs. All right. If everyone could just give me a thumbs up once they have been logged in successfully, that would be great. If you're participating. Once you see
that, where do you do that thumbs up on Zoom? I forgot.
Yes.
It's
So,
on reactions. So
oh, got it. Thank you.
Yeah. You can also use the raise hand feature, but feel free to shout out and shout out your questions. As Ricky said, we're trying to keep this as interactive as possible.
all right. So I think we have a good amount of people who are ready to go. Then I want you guys to go to user profile and then click on account details to add some premium credits that we'll provide, as well as access to our lab environment manager and our SDK. Get it now before we build our subscription model, which our team will get on in the next few months. So I recommend.
Sorry, where did you say, sorry for interruption. Where did you say to go, please?
Yes, so the link is right here in the chat as well. Go to account.qbraid.com/user profile. You can also click on your little icon here at the top right and just click profile, then click on account details. Once again, if you guys could just give me another thumbs up when you guys are done with that, that would be great. And once you are done with the portion, I'm going to talk about a few things. And before that, I'm going to talk about our learning portion and kind of how to get started there.
Ricky, sorry, I think the code is not working, the one you put in there. It says people are having problems or
Right.
It's ENHU6626, right? Oh, sorry.
So.
EHNU. Sorry, guys. I think it was my mistake to put something wrong.
Yes.
Yeah, EHNU, right? Yeah, got it.
All right. So thank you, Mary. Yeah.
So while you do add the code, I'm going to talk about some of the learning platform components we have,
And before that, I want you guys to just make sure to click Launch Lab. This will take you to.
Sorry to interrupt you again. Where do you click the
that's-
code? Sorry, you're going a little
Yes.
too fast. Where do you click the code, please?
So you click on, do you see the icon at the top right with like a face on it? You see where my mouse is?
Yeah.
Okay, click Profile.
Oh, okay.
Yep. And then
That
just click
was-
on Account Details.
Details, account details, okay.
Yep. Then add your code.
Add your code where?
In
Add
the
access. Okay. Wow, that's a lot of information for someone to get. I think you slowed down a little bit. It might be,
Sounds great. Yes,
Yes,
I agree.
really, that's a lot. How would somebody know that on their own? And you're moving to the next topic.
Yep, I agree. I think there's a lot of
Thank
the UI things that we constantly forget when we're developing because we're so used to just like,
Yeah,
building
you're
the
very
product.
enthusiastic about it, but for many of us who have not seen this before, wow.
yes.
But I guess we'll, okay, please continue. Sorry I interrupted.
No worries. Thank you so much for the feedback. I really appreciate just getting to understand what a first-time user goes through because I think I just forget about that so often when I'm just like kind of coding.
By the
on
way,
it.
I've used the program before in its previous incarnation. I learned a lot from it. It was really cool. The animation, and all that. So this is a nice change. All right.
So while once you guys are done, just click on Launch Lab and it will take you to your Jupyter Lab, which is very similar to your like IBM's quantum computing, as well as Penny Lane's new Jupyter Lab environment. But we do have the strength of being completely agnostic. We have devices from Xanadu, AWS, as well as we will have IBM's 27 qubit quantum computer in a pay-as-you-go format available through our services as well. So what's great about Jupyter is that we'll have access to all of these in one place. All of these devices and simulators in one place. So while that's loading, it will take a little bit because if you have a new account, we have to kind of build up some of the information with regards to your file system and whatnot. So in the meantime, is everyone okay with that? Any questions so far? Just, all right. So while that's loading here, just click back to account. And I'd love to showcase some of the things we have. If you're completely new to quantum computing, we have a course that's available where you can then click on launch course. Then when you launch this course, you have a really interesting way of tackling quantum computing from a beginner's perspective, where we cover the mathematical perspective, computational perspective, and the quantum mechanical perspective in one kind of way. And we do this in a highly interactive format. Just like this talk right now, we like to keep things really interactive so you can understand like coherence and decoherent waves as well, or constructive and deconstructive waves. Then you can also run your own quantum circuit. And then once you have understood what you have written there, you can then go back to Jupyter Lab and then start coding your own programs through qBraid. This course has been endorsed by the White House Q12 initiative, and it's been used by various undergraduates as well as other groups. And I highly recommend it because there's also videos provided by Andrea Coladangelo from Caltech. All right, so this is a great format. And one more thing is that we've kind of adapted this to also provide people an easy way to essentially write your own blogs. So the same backend is used to allow you to say, write about a blog about single qubit quantum tomography, and then other people can then just copy it, launch it on their own lab, which means that you can just copy this notebook in. And for example, just run it without any installation and learn more about a topic that someone else has written about. All right, was that okay? Don't want to go too fast here. If anyone has any questions, do let me know. All right, so we have blogs and like a textbook of sorts. What's great is that it's like Medium. If you've ever ended up on Medium and are like, why did this person copy an image of code I have to then like, I can't even copy it. I have to actually like type it in. Now you have like a platform with regard to quantum computing or just any, any Python in general, where you can quickly just update it and then run it and then test it for yourself and write your own cells as well. Yep, so this is completely editable. So, and it says all right. I think your lab should have been loaded right now. You should come to this screen. You may have much less stuff than I do. Give me a thumbs up if you have gotten to this screen. Oh, also, hi, Callum. Great, everyone is here. This is great. Sometimes way back when this part used to crash. So I'm glad that we've gone through this. Then what I would like everyone to do is click on the top right, ENVS. I'm going to make it a little bigger. Click on ENVS, then click Add. Then you should see the qBraid SDK here. I'm going to uninstall it. So this should show up on the other side, and I would like everyone to install it. If everyone could install it, that would be great. I'm going to uninstall it so then I can follow along with you guys. It does take a little bit because it is a large package, but our qBraid SDK allows you to write your circuit in, say, Qiskit, and then send it to an AWS backend without flaw. So we've done some we've done some testing of our SDK where we've had several randomized circuits created of various depths as well. And it has performed and has achieved 100% accuracy as well. So with that said, what we want to do now is you should see the SDK on your top right after you click on Add, and then you want to install it. All right. So while it's installing, I'm going to show you some of the documentation that's available to you. First and foremost, say you're not ready to maybe or you see another package, or you see that, oh, what's Pulsar? If you're interested in each of these, we actually provide you all the documentation in the Quantum Docs page. So as soon as you are on qBraid, not only do we provide you tutorials, but we also provide you the documentation, which can get you to read the docs immediately. So whenever you're confused, you can use that. Secondly, what's really great is we also provide tutorials as well. Tutorials from the largest providers, including Google, IBM, and Amazon, Microsoft, and even Python tutorials if you're unsure about how to use Python. This is just a great way to get started. And while this is loading, I'd like to just get started with everyone by going to Amazon Brocket and clicking on the Getting Started folder. If anyone has any trouble getting to this part, please let me know as well. So then what you want to do is then click on _running quantum computers, I think on Amazon Brocket, on QPU devices actually. All right. All right. Is everyone here now? Can I get a thumbs up? Any issues, questions, comments? All right, sounds good. So if everyone is here on this page, we're going to then access Amazon Brocket computers with the credits you've gotten in little to no setup. If you did this through AWS, you're gonna basically have to go through setting up a lot of cloud-based stuff.
Ricky,
Go ahead.
we have a question from Prosanto. Do we need to install brackets in environment? That's the question.
Ricky, you're muted.
Yes, that's a good point. Great catch. You actually got me there. Yes, you do need to install it. Make sure that it's installed as well.
Good. And can you like emphasize that point again? Are we actually using quantum computers right now?
We'll get to use quantum computers through qBraid. What you usually would have to do is you'd have to make an AWS account and do all these like things that may or may not be familiar to someone who has only a quantum computing background or has never done any cloud or DevOps. So what we do here is we make it super easy. You will run this command, and from here on out, I'm going to show you that you can actually access quantum computers. Now, again, quantum computers right now are very nascent. They have to be calibrated, and there's some times when they're not available. So,
Yeah, but
for example,
just to reiterate, in around 5 to 10 minutes, we were able to put in our Google account and then run for free on a quantum device.
Yep, exactly.
Okay.
Yep. And that's kind of like the magic of qBraid. We are going to be adding a few more quantum computers on our platform. Hint, hint, some of them are going to be neutral or Rydberg atom architectures. And we hope to be able to provide as much breadth and access to quantum computers as much as possible. And that's something you just can't get with other providers. That's what we want to be in this space. All right. So please go through the same process of activating the Amazon Brocket environment. Once you have done so, you can go here and enable Amazon Brocket. It should work. And make sure that your environment is set to Brocket as well. This is the most confusing part. I think this is the one thing that we want to improve on our side, is that we want people to not have to always click on and activate the, a certain kernel. So if you have any issues there, just let me know as well. qBraid does take a while to install. So this is kind of why I'm taking a segment into just using Amazon Brocket first, because the qBraid SDK is going to allow you to transpile between some pretty large packages. Yes, that is correct. I forgot about that. That's a good point. So you do have to wait for the SDK to install. Okay, so we can kind of wait, but I can, in the meantime,
When you're asking questions, could you also like tell the question, because when we're recording this, they're not going to be able to see the chat on YouTube.
Yes. So first off, we were asked about installing Amazon Brocket. That is correct. We do need to install Amazon Brocket for this demo. And then the install button is grayed out for me. You're correct. We do not have multi-environment installation right now, but that is actually something that I didn't think about for this demo. And I'm glad you've raised that, Prashanta. Thank you. You certainly could use the Amazon qBraid SDK as well. You just have to simply activate the qBraid SDK environment here. Oh, whoops, I need to activate it first. So once it's activated, you can actually just switch to the qBraid SDK. And then just change right here on this line, qBraid SDK. And make sure that your circuit is still running. I think it's still disconnected, so I'm going to restart. I'm going to wait for it to be restarting. All right. And why it's not connecting. Okay. Is the SDK installed for everyone? Thumbs up. Good. Cool. I'll wait for a few more thumbs up. All right. So once you have the SDK, make sure that you've activated the SDK on your environment here. So make sure it says active at the top right. Then also make sure that you've selected the kernel to be the SDK. This is my pet peeve right now with our UI. We do want to make this a little bit smoother, where we don't have to click on so many buttons. Once you have done so, on the very first line, it's going to ask you to enable the Amazon Broadcat. Please change it to qBraid SDK, and it will allow you to then successfully access AWS quantum computers, simulators through qBraid. All right. Once you have done this, you can then move to essentially start installing all the necessary packages, and then get all the device gate sets that are available from the quantum computing QPUs. One of them is actually from Oxford. It's, Oxford Quantum Computing's Lucy. And I don't know the availability at the top of my head, but it might just be available for us to run some circuits. Question. All right, thank you for joining, Nathan. Hope everything's well. All right. While Broadcat is getting installed, I recommend then we're going to just run a bell circuit on a local simulator first, and you will get your results. Then you would also want to then maybe, I don't think Rigetti is always available, so we're going to skip it. And we will run it on IonQ with 10 shots. All right, so Broadcat was installed, and now you can see the gate sets that are available through the SDK. Rigetti, IonQ, and OQC, these are all available to you, as well as the SV1 simulator. Okay. Please disregard that error, and just get to the section where it says,
Ricky?
yeah, go ahead.
Yeah, sorry, I just can't seem to find this notebook running quantum circuits. Could you guide me where it is, in which folder? Okay, cool, I see. Yeah, okay, I see it.
Thanks. Vansh, if you have any questions, just let me know, or if anyone else does as well. We're going to start running on quantum computer. So basically in under 5 minutes, you're able to, in under 10 clicks or so, you're able to now access a quantum computer and start running your jobs. That's kind of the beauty of qBraid. And not only this, I'm going to show you what the really powerful thing about the SDK is that say you love writing in Penny Lane, you can then rewrite your circuits into Qiskit with a few functions. So that's kind of what we will do, and we'll show off in a bit. So without further ado, I just want to show off that we can run on an IonQ device. And usually this would require a lot of setup, but this is all done. And then you'll be able to queue it and then get the status of it. And I do recommend changing the shots to a lower value so you don't use up all your credits for a demo. All right, maybe OQC is also available. So, oh, I actually didn't run the circuit, so I'm going to uncopy that. Great. So OQC is also available. And now you're able to run your circuits on IonQ and OQC. So boom, there you go.
Is there a way
You just
to
ran.
is there a way to see where we're in the queue, or like how much average time that you need to wait? Because each device is different, right? If you were like Oxford
Mhm.
quantum circuits might make you wait longer than let's say IonQ.
Yes, great question. We are currently, AWS doesn't allow you to do that because they're kind of like managing a queue with IonQ's own queue. So we don't have access to that, but we are building our own queue as well. We will have like a quantum job management extension that is actually already internally kind of working. And so we will have it right below the M's. You'll see like quantum jobs, and then you'll be able to see, oh, where my jobs are getting ran. When is it taking what? And right now, if you're unsure about when it's getting run, you can also just check on the dashboard and see what's in progress as well. So here is also, it's not like a queue but it's your personal queue.
Yep.
So, yep. All right. So hopefully we can actually get our state back. And then we should be able to then load in our task as well as the, yes, so we'll have to wait for it, but eventually what you get is your probability distribution or a shot count distribution as well. Oh, you're getting a client error when you run on. Make sure that you have activated the qBraid SDK, qBraid jobs enable qBraid SDK, or the Amazon bucket, depending on which one you're using. And then secondly, just make sure that you have like a dummy S3 folder that's been added in. So you may need to just add the S3 folder here to specify as well. And that question was with regards to a client error where you were running on IonQ. I'm going to clear out the two just to. See if it's done. All right, it is taking a little bit, but if you have any questions, these should just run and you should get your results. And Prashanto, if you have any issues again with the client error, just let me know. I'd like to move on to another section of our demo today, where we will go over the qBraid SDK, if everyone's okay with that. I think the OQC one should return at some point, but we'll see. So while we wait, I'm going to share you guys the qBraid lab demo. This is the GitHub link to it. And I'm going to talk about what this does. This is a lab demo for our SDK. And our SDK, once again, if you want to run on Circ, if you want to run on PennyLane, PyQuil, or any of these other languages from Qiskit or from any other language, it just provides a framework to framework translation or transpilation.
Could you zoom in a bit, Ricky?
Yes. Make sure to give this a like or a favorite if you have a GitHub. And once you've done so, we're going to show off another feature here that we've built, where you see a button here that says launch on qBraid. Please just click on this button and it will take you back to your account, and then just clone the repository for you. So for example, if you're working as a team, like this is a good way of just like adding it to your GitHub repository. So then you can immediately clone it into anyone's account if they're interested in contributing, as well as they're able to. This has been great for hackathons because everyone has like a challenge repository. We've worked in a lot of hackathons now, and it's just like, boom, just click on the button and you're ready to go. Just make a new branch. So this is kind of one of our cells as well. All right, so now you should get to this demo repository. What's great is you also can maintain a lot of your Git functionalities here with the Git extension. I personally like to use the CLI. We give you full access to our qBraid CLI here. You can not only use the qBraid CLI to activate any of the environments that you have installed. This is exactly like Conda, for example, where then you can pip install anything that you find necessary into that environment. Not only that, but I'm pretty sure, I don't remember the correct syntax, but you can also make sure to get your credits as well. So qBraid jobs get credits will also show you how many credits you have left, as well as it will list all the jobs that you have been running so far as well. And this is just basically the non-UI UX version of the extension that you see on the front end. All right. With that said, I'd like to click on the very middle one here, the qBraid SDK devices and jobs demo. So once you've cloned this repository, you should get this one in the middle. And I'm going to just talk about the SDK again and make sure that you've activated your SDK as well. There are some small minor changes to the syntax that we'll have to walk through. Can I just get a thumbs up from everyone that they're following still? I feel like I've gone through a decent amount of stuff. Okay, cool. So the SDK was developed by Ryan, our CTO. He's done a fantastic job. First and foremost, once again, if you've already enabled it for the SDK, you don't have to enable it again. In this demo, I think there's a -n here. We've removed that syntax, and now it's just qBraid jobs enable. Please change that if you haven't done so already. Then next, again, importing the qBraid environment does take a while, but please run this cell. You may see like an IBM Q.save account. So I might need to import IBM Q actually. But
so that qBraid import, that's internal, right? You can't just like make a call and pip install it to another environment. It's not an API that we can access outside of qBraid.
Yes, right now we're kind of still debating on what we want to do as like what we want to do with, do we want to make it like half open source? Do we want to make it completely open source? You know, the qBraid SDK can be really valuable in terms of just from a strategic perspective, like, oh, I can use the SDK on qBraid and like I can transpile like my circuits, so then it's easier. Yeah, that makes sense.
What about exporting? If I wanted to export a notebook out, it will, I mean, it will make sense because it wouldn't run anywhere else. But let's say I want to export an IPython file, IPython notebook file.
Yeah, with the SDK, correct?
No, like from like, okay, this is on GitHub, so this is possible. But let's say on the first tutorial that we did.
You're thinking of like exporting the kernel? Is that what you mean?
No, just the notebook itself, the IPython notebook file.
Yeah, so you can just download it here. You can actually download any of these notebooks locally.
Yeah,
we will have a sharing feature soon. That's been voiced by a lot of people. I think that's just been something that we haven't quite gotten around to yet.
great.
Yeah, it's just a little tricky to do the sharing thing correctly. But what's also there's many ways of actually doing this. You could actually even like publish a notebook here and then just like clone it from the media page if you wanted to. So,
Oh, nice.
but your friend could just post a notebook and then you can just click on it,
Mhm.
and then just click on launch on lab here. So launch on lab. I don't know why it's not working, but it should work. Anyways, basically you should be able to launch on lab and share it as well. All right, coming back to this demo. Once you've imported qBraid, you can run the following cells. Oh, where am I? This one, yep. So just run the following cells here. These are all the devices we have available. We'll be continuously updating them as well. And here you can also query for certain devices that you're interested in, similar to maybe like a database search, and it will return you the status and its availability. And if you're looking for a QPU, you can once again check the status and availability of these, and these are updated real time. And you can also refresh it on your own as well. And now what I want to do is on this cell here, where you're going to run your device wrapper, and I'm going to show you how you can write one circuit and then send it to multiple devices and providers. If you have any questions, again, let me know. This is where we're going to skip some of these IBM things. We don't have everything configured right now where you don't need to add your credentials in. So I'm going to clear all outputs here. And so we're going to have to kind of skip around here. We're going to make a quantum circuit using Qiskit. You get your circuit, then make sure that these are commented out. Specify your number of shots. Create your device wrapper for Google and AWS simulators. And boom, you're able to now run your Qiskit circuit on Google and AWS at the same time, get your jobs back, and then get all of your results as well. So I'm going to, we haven't run an IBM Q job, so I'm going to actually comment them out here. So I'm going to do this, and then you should get your results from each of them, and then you can then compare your results and plots. So you have your, see, you can tell that actually my Lucy job is still running, and then my IonQ job actually just finished, so I can actually go back and check on that now. But okay. If you're following so far, I am uncommenting a few things, but boom, you're now able to get your results from AWS and Google. And since they're simulators, you get the exact same results. So if you love Qiskit, but you don't want to learn how to write in Circ, for example, or there's some functionality in Qiskit that you really like, maybe there's some like multi-qubit gates that you want to use, this is perfect for just kind of like transpiling exactly and then sending it to multiple devices as well as simulators. Has everyone gotten to this point? I feel like there's a lot of skipping around and uncommenting. Point of it is, if you see IBM, just uncomment it because we haven't implemented it yet. And what's been great is we've had some use cases here. Not only have we tested this at hackathons, but we've done like a workshop of sorts where we've run on an IonQ device using Qiskit as well as Amazon Broadcat. And that was pretty cool. And we also ended up running it on Rigetti as well for one algorithm for like a quantum financial optimization algorithm. It's the one you find on like the Qiskit textbook for options, I think. European call options, I think. So, and we get comparable results with just running it on a 5-circuit quantum computer provided by IBM. that's kind of the end of the demo. If you have any questions or if you got lost, just let me know. But this is kind of where we're headed. What we're going to do is start beefing up the qBraid SDK to include like more specific or industry or research specific kind of applications, such as like polystrings for quantum chemistry and whatnot as well. So, yep.
Amazing. Well, thanks, Ricky. It seems that you guys have like built a lot. And yeah, let's open the room for questions.
Thank you, Merritt.
Yeah. I guess I mean, I wanted to talk to you about a bit on outside of qBraid context on how you move from an university education to building a product, right? So maybe we can talk about your background briefly and how does someone actually get started on contributing to this community, right? Because we're pushing the boundaries of frontier technology, but how do you actually do it? How do you accomplish that? From fundraising to joining academia to getting the proper education at an undergrad or even high school level, right? Because that's what you're kind of allowing through qBraid as well. If I'm a high school student, I can just go on to your platform and in 5 minutes I can start learning and using quantum computers. So maybe we can talk about that briefly. How does one start building?
Yeah, that's a great question. There's so much that you can do and start building. I think we are trying to move towards, just to clarify, like we do love our high school users, but we do also want to make money. So we are very interested in like enterprises as well who are getting started in quantum. But again, like the problem there is relatively the same thing where right now, no one really has like a quantum mechanical background. And even if you have a quantum mechanics background, quantum computing may or may not have been taught. So some of the conventions of using like unitary gates and whatnot might not be as familiar to someone who didn't take like a quantum computing course, for example.
I was more asking in terms of not like to your like qBraid user base. I was giving qBraid as an example. You can do the same thing with like picking up like a book or like going online and Googling and or trying to go to IBM Q. I was more like trying to understand your journey, how you started learning about quantum computing, and like because you are a young entrepreneur in your career, and it seems that you guys have built a lot of stuff. So I just wanted to emphasize that journey and ask you about how did it start?
Yeah, that's a great question. I think in high school, I really liked physics. I was really lucky to have a great physics teacher who did all of like the very basic demos that would astound anyone. Like I don't know, like something simple as like the brachistochrone problem was like astounding to me because like I was so rooted in some non-physics based understandings of this world. So that's where I was like, okay, I was lucky enough to get into Stanford, and then I kind of asked myself, like, I could do CS like everybody else, or maybe I can actually take a gamble and do something that I enjoy. And that's where I was like, okay, physics might be something I really want to do.
Clarify. A lot of people do computer science at Stanford. That's
Yes.
what it's alluding to, because it was the most, while we were there, it was the most prominent major that led to I guess a successful career. That was the convention. But yeah, sorry to interrupt you. Go ahead. And we're getting a few questions in the chat as well. But yeah, please go ahead.
Yep. So that's where we have kind of that's where I started. And you know, everyone does CS, but then I was like, if I'm going to learn CS anyway, and you know, there's so much online resources, I might as well do something really exciting and interesting. And that's where I got started in quantum physics and then quantum computing. And then, you know, I really had the privilege of just joining in on qBraid when Kanav was just getting into duality. So it was myself. There was a prior team, but then they all went back to school. The pandemic was kind of over. So then it was myself, Kanav, Ryan, and another person named Graham, who kind of also went to work in a different job. But essentially, it was the four of us that entered into duality. And that's where my bet was right. I was gonna learn CS anyway, and I did. And and by I did, I literally mean like most of the stack that you touch on qBraid, I have a good enough understanding that I can bring it back up if it crashes in around 30 minutes max. So yeah, it makes you highly employable to work at a startup, to be honest, because you understand a lot of the small things and the big things about strategic vision and building a product and managing people as well. So
yeah, I remember you showing me your product, like the first prototype maybe a year or more ago, maybe 2 years ago. And I was like, wow, this is great. Like, who built this? Who did you pay to build this or something like that? And you were like, we built it. So yeah, a lot of time has passed since then. And maybe you can talk more about your role a bit, like chief organizing officer, right?
Yeah, I mean, the title is not does not really accurately depict what I do. I think there's a lot of just day to day I am coding as well as organizing events. The tough part about Quantum is everyone is in the same boat where there's no actual industry application that's like going to maybe like for a company save them 5% on the bottom line, for example, right now with quantum computing.
But then, okay, you're saying that you said you skipped computer science and wanted to do something that felt right for you, and you did physics. And but because your idea was that you were going to code anyway, you were going to learn computer science anyway, and your day-to-day job, you're saying now involves a lot of coding. So what is the argument for learning physics? What's the argument for learning quantum mechanics instead of computer science? Because if I'm coding every day, why not just skip that, all of that, like material on physics and focus on computer science?
Sure, that's a good point. I think what I would argue with that is when you're a small startup, you kind of have to pull yourself from your bootstraps and do have to code your front end classical stuff. But in terms of an education, you shouldn't do something that like anyone can kind of do. And like, not to put it rudely, but like this is not something where you know, if you're going to spend a lot of money on an education, you should probably enrich yourself in a way that really changes your perspective and improves your perspective of like understanding ground truths about this universe and about this world. And I think that's like much more important than being able to, you know, make a recursive function because that's everywhere.
Well,
so,
yeah. I mean, you know that I completely agree with you, but we're biased as physicists. So I can see Vanch smiling over there. He's just started second year here at Oxford.
I can relate to the whole physics versus CS journey. The whole I can do CS anyways. I might as well do physics, which is why I was laughing.
Yeah, and just to add, like, sure, I had to code for like a year and a half. But I got most of this stack running in a year and a half as well. And like that with no background whatsoever. And then, but like, where will be the interesting gains? Where will be the parts that like, if you want to make genuine impact? Well, that's not going to be in, you know, making it.
The lab course had some like Jupyter notebooks in it, right? We were using at the physics lab course.
Yeah.
It did have some coding at least. But again, yeah, you can make the same argument for other places in the world where, because in the United States, especially in California, computer science is the most prominent area right now, but especially at like schools with a technical focus. But you can make the same argument in other places in the world where like law, where you can do law as an undergrad is the most prominent successful major, right? It's deemed successful by others, and it's the most popular one, or I don't know, business, for example. So it actually doesn't. It's not specific to computer science. Here we're talking about computer science because you can also approach quantum computing from a computer science perspective. But yeah, of course, Ricky did something where he wanted to learn about physics, and he wanted to learn about the truths about the world and about the universe. So he went on with that path. Do you actually use any of the stuff you learned in let's say physics 130, quantum mechanics, physics 131? Like
I think maybe not 130, but I mean, there's a good amount of it because like ultimately our goal is to make quantum applications or like to integrate quantum applications. There's a lot of just like, if you're running on this device, you have to actually think about your gates and unitary matrices and how you'd apply them. And I did learn that in 134, as well as just like when you are even thinking about like what you say you're trying to embed a circuit.
134, just to tell everyone what it is. It's the quantum information, advanced quantum mechanics and quantum information, something like that, right?
Yeah, I was going to ask for those of us not from Stanford, what is 134?
Yeah.
So that was taught by I guess Patrick Hayden when you were taking it, right? Or did you take it?
I learned I had the privilege of taking the course with Douglas Stanford.
Okay.
Yes. But again, like those are things that you learn a lot and then you have to go apply it. And just being able to think about Hamiltonians as well is not something that like I can take for granted. You know, those are things that are really, really helpful. And Kanav has a PhD in quantum chemistry, so there's a lot of like Hamiltonians that he's familiar with, and I wouldn't be able to parse any of it if I didn't have a quantum mechanics background simply. So yeah.
And you said 4 people joined duality, and how many of the, like, can you tell about a bit about the backgrounds? Kanav is the founder and I guess CEO, and he did his PhD and in quantum chemistry, you said. And then you did an undergrad in physics, and you said 2 more people, right?
Yes. So we're all physics background. Graham is no longer with us. He's in the Navy. But Ryan is the CTO, and he has a background in CS and physics.
Oh.
So he's from Cornell. And you know, I think there's a good reason why he's the CTO, because his code is like so clean as someone who's done a lot of open source and hackathons. What's really unique, I think, is all of us can code, obviously to certain degrees, that we can do JavaScript and stuff where, you know, some PhDs are not always like susceptible to coding. Conda environment might scare them, which is also kind of where we provide an easy way to like interface with package installations on qBraid too. So we're coders and physicists at the same time.
Good. And then for people who wanna get involved with this industry, Dan, what would be your advice in terms of education? Would you like advise them to get a PhD? What would be the one final point, expounding on your journey?
I think what I've realized is, of course, a PhD is nice, but maybe like you may not have the opportunity to have a PhD just because of your financial situation or just whatever. If you're still interested in quantum, like you can certainly do very compelling things by joining open source communities, joining Quantum Open Source Foundation, as well as Unitary Fund, because there are researchers who are working on genuine problems and working on like contributing to them. And that's actually where a lot of industries like to see, like, oh, this person is on their journey to getting a PhD, for example, and they're like genuinely contributing to something that I use on a daily basis. So then that's actually one of the easiest ways in, because you get the visibility and you also get the practice of coding and then producing like things that other people will use for research. I think, yeah, joining in on these communities is, I think, very, very important.
Yeah, definitely agree with that. I think learning takes place collaboratively. It's not, maybe some people can read through a textbook and then do problems on their own without talking to anyone. But from my experience, I learned the most when I'm struggling through something with other people. And there's a lot of things to struggle with, especially in quantum mechanics. So great. Well, do we have any last questions?
Yeah, I think we have like 2 questions from the chat, if I can read them out. So Tom asks, how receptive are the quantum companies like IBM, Amazon to your idea? Because surely they want users to learn their own language, right? Instead of just bypassing it with qBraid.
Yeah, great question. So what in the demo, we ran a Qiskit circuit, and then you could actually do the same thing with a penny lane circuit without gradient tapes. You can run it on PyQuil, you can run it on Brocket, you can run it on any of these circuits and then just send it to a device. So it's really, we're not doing like a import qBraid from qBraid import qBraid circuit. We're actually doing qBraid import whatever circuit you want in whatever language you want, where the companies can perform their own user acquisitions. And then if a user has ever gets stuck on, oh, darn, I need to use this device, or, oh, like a penny lane QML kind of like implementation on top of my Qiskit thing would be nice or something, qBraid is there. So we're just like a middleman of sorts. And they're very receptive. They're very happy to do this. Yeah.
Yeah, I know, fair. And there were a few questions. There was one question about the hackathon that qBraid is organizing. I believe it's called Hacks. Someone wanted to talk about, can they join in to listen to all the talks for the hackathon itself? I'm not very clear on what the question is, but it says, can I join to listen all great talks?
Yes, please join in. I think we have Will Oliver speaking. We have like this really cool like CTO like panel thing going on as well with Pascal, the neutral atom CTO, as well as Pranav Gokhale from Cold Quanta. And I think one more technical individual, as well as Rajiv Krishna Kumar, I think, from Goldman Sachs. Like, these are all great talks. You don't have to hack. You can come to the talks. I would highly recommend coming to them. It's a pretty stellar lineup. So please do. And you can sign up by clicking on your account and just clicking on the Hacks tab and then just filling out the form.
Yeah, I'm already signed up, just to let you know.
All right, great.
Yeah,
Let's wrap up. We're past 7 p.m. If there's anything else, you can ask now. All right. If not, all right. Thanks everyone for joining.
Yeah.
Of course, thanks to Ricky who spent an hour with us.
Yeah.
Yeah, we have many exciting events coming up. I think next week we have a social event. There will be pizza on Oxford campus. And then the week after that, we're hosting Jack Hidary from Sandbox AQ. Jack already sent us a few copies of his book, around 25 to 30, that we'll be distributing during the event. And yeah, everyone else can join online who's not at Oxford, and this will also be available on demand, like as we're doing now with Ricky's talk, recording it. Yeah, all right. Thanks everyone.